Assalamu alaikum dear students. In previous lecture we discussed the geometric mean. Today we are going to find the relation between the geometric mean and the arithmetic mean. How we relate these two means between any two numbers. Now let A and G be the arithmetic and the geometric mean respectively for between any two positive numbers and B. That is, A is the arithmetic mean between A and B, while where A and B are the positive numbers, and G is the geometric mean between these two numbers. Then we know that by the definition of arithmetic mean, A equals to A plus B upon 2, while G equals to root of A into B. Now A minus G equals to A plus B upon 2 minus root B, which is by cross multiplication A plus B minus 2 root B upon 2. Now this A can be written as root A square, B can be written as root B square minus twice root A root B, because A and B are both positive numbers. Now here this very expression, this term root A square plus root B square minus twice root A root B becomes root A minus root B whole square upon 2. Now here this is this fraction, that is root A minus root B square, is positive, 2 is positive, which implies that this whole number is greater or equals to 0. Now this equals to 0 only when root A equals to root B. This means that overall term is greater or equals to 0, means positive, which implies that A minus G is always greater or equals to 0, or A is always greater or equals to G. This means that arithmetic mean between two numbers is always greater or equals to the geometric mean. So this is the relation between this arithmetic mean and the geometric mean between two numbers. Now we will start this exercise, and question number 2 of this is: find the 12th term of GP whose 8th term is 192 and the common ratio is 2. Now we have to find its first term, this 12th term. Let A be the first term. A be the first term. Given R is 2, that is common ratio is 2. We know that for GP whose first term is A, common ratio is R, that is 2, is given by A n equals to A R raised power n minus 1. This is the general or nth term. Now this equals to A raised power A into 2 raised power n minus 2. Also A8 means 8th term is 192, which implies that 8th term according to this an is A into 2 raised power 7, because n is here 8, is 192, which implies that substituting the value and simplifying it, A equals to 3 by 2. Hence 12th term is A raised power A into R raised power 11, that is 3 into 2 raised power 10. So 3 into 2 raised power 10 is the required 12th term of GP whose 8th term is 192 and common ratio is 2. Now the question number 3 is: if 5th, 8th and 11th terms of GP are P, Q and R, we have to prove that Q square equals to P into R. Let A be the first term, R be the common ratio of this GP, which implies that nth term is A into R raised power n minus 1. Now A5 is A into R raised power 4 equals to P. Name it equation first, because it is given that 5th term is P, 8th term is A R raised power 7 equals to Q, because it is given 8th term is Q, which implies that squaring both sides, Q square equals to A square into R raised power 7 whole square, which is A square into R raised power 14. Similarly, A11 equals to 11th term, A into R raised power 10 equals to R, name it second. Also Q square is, this 8th term is Q square, which is A square R raised power 14. Now this square can be written as A into A, and R14 can be written as R10 into R44, because bases are same, power should be added, which implies that arranging this, because multiplication is commutative, it is AR4 into AR raised power 10. That is AR4 is P from first and AR10 is R from 11 in this from second, which implies that Q square equals to PR. Now here we have given GP which term of this GP is 1 upon 19683? Clearly this sequence is GP because ratio is same throughout. First term A is 1 by 3. Comma ratio is second upon first, that is 1 by 3. Now let this term, this given term 1 upon 19683 be the nth term, which implies that an equals to a raised to power n minus 1, which is 1 by 19683. We assume that this term is the nth term, which implies that substituting the value a equals to 1 by 3 or equals to 1 by 3 after putting or raised to power n minus 1 becomes 1 upon 6561. Now r is here 1 by 3, which implies that 1 by 3 whole raised to power n minus 1 is 1 upon 6561, but 6561 is 3 raised to power 8, which implies that 1 upon 6561 becomes 1 upon 3 whole raised to power 8. Now when bases are same, power should be same, which implies that n minus 1 is equal to 8 or n equals to 9. This means that this given term is the ninth term of this sequence. Now find the sum of 20 terms of GP which is this GP, that is first term is 0.5015, second term is 0.015, third term is 0.0015, so on. We have to find its sum up to n term, up to 20 terms. Clearly first term is 0.15, second this comma ratio is second upon first, that is 0.1. Clearly this 0.1 is not equals to 1, which implies that we know that the sum of the n terms of GP whose ratio r is not equals to 1 is given by Sn equals to a into 1 minus Rn upon 1 minus r, which implies that S20 becomes a into 1 minus R20 divided by 1 minus r. Substituting a and r, we simply get this 5 by 6 into 1 minus 0.1 raised to power 20. So this is the required sum of the first 20 terms. Now the 11th question is, we have to evaluate this very expression. Now clearly summation k runs from 1 to 11, 2 plus 3 raised to power k becomes, we break the summation, that is summation k runs from 1 to 11, 2 plus summation k runs from 1 to 11, 3 raised to power k. Here we have to add this 2 up to 11 times. So it is 2 plus 2 plus 2 up to 11 times. 3 raised to power k becomes 3 plus 3 square plus 3 cube plus so on to 311. Now clearly here this 2 plus 2 up to 11 times becomes 2 into 11. Now here this term is GP because its first term is 3, its comma ratio is 3, which implies that the sum of the first 11 terms in this GP becomes a into r raised to power 11 minus 1 upon r minus 1. Here r is 3, a is 3, so substituting the value we get 3 into 1 minus 3 raised to power 11 upon 1 minus 3, which is 22 upon 3 by 2 into 3 raised to power 11 minus 1, which implies that 22 plus 3 by 2 into 3 raised to power 11 minus 1 is the required sum, is the required number. That is, this k runs from 1 to n, summation k runs from 1 to 11 and 2 plus 3 raised to power k is actually the number 22 plus 3 by 2 into 3 raised to power 11 minus 1. So inshallah in tomorrow's video lecture we will discuss further this exercise 9.3. So thank you.